Definition of sequence. A sequence is a set of objects or numbers that are in order. And what is a rule? A rule is a way, or sometimes it is a formula, to find the value of each term in a sequence. And just to give you one example, here we have a pattern, which is a sequence for which you will notice that the next number is defined by adding a certain number to the previous number. In this case, we have our 1 here as the previous number, and if we add a 3 to 1, this gives us the next number 4. And if we do that same procedure, we can easily reveal the next succeeding number, such as the 7. So adding a 3 to 4 gives us 7, adding another 3 gives us a 10. So this pattern of continuously adding a 3 is now a rule. And let us proceed with some of the vocabulary related to sequences. So here is an example of a sequence for which we are calling such numbers by specific terms, such as the first term or the initial term for our first number 1, while here is the second term, while this will obviously be the third term, while this will be the fourth term. So you will notice that there is an ellipsis here, for which this suggests that there are infinite numbers of terms in this particular sequence. That means that the list of numbers goes on forever. And now let us consider the finite sequence. So what is a finite sequence? It is said to be a sequence for which it has an exact number of terms. So let me give you an example. So here, you will notice that we only have an exact number of 4 terms in this sequence. So this is said to be a finite sequence for that particular reason. And to further realize what do we mean by finite sequence, let us proceed immediately with the other type of sequence. This time, it is the infinite sequence. And what is an infinite sequence? So it is said to be a sequence for which the terms goes on forever, which is usually indicated by an ellipsis. So here, you would notice that we have a list of numbers, but this ellipsis suggests that the list of numbers goes on forever. So this is an infinite sequence for that particular reason. Generating sequences. So here the main goal is to generate the terms of a sequence from its rule. So it only requires simple manipulation procedures that you are actually familiar with. So like for this example, you have to generate the first 4 terms of the sequence that follows the rule 3n minus 5. So the basic idea on how to deal with this kind of problem is to apply the substitution property. So here is a guided explanation. You may take a screenshot of this for review purposes. So if once we take a look at the solutions here, you would notice that this is basically 3n minus 5, for which the value of n changes relative to the position of the term. So since this is the first term, the n changes to 1. And if you take a look at the second part of the solution, this is basically 3n minus 5, for which the n changes to 2 because this is the second term of the sequence. While here we change the value of n to 3 because this is our third term. While here we change the value of n to 4 because this is the fourth term. So you just have to manipulate the resulting expression for you to come up with the values for the sequence. And if we take a look at the next example here, you will notice that each of this are actually 4n plus 3. Again, we are merely changing the value of n relative to the position of the term. So here we have our n be equal to 1 because this is the first term in the sequence. While here we have this value of n be equal to 2 because this is the second term. So here we have a 3 because this is the third term, and here we have a 4 because this is our fourth term. So lastly, we have a value of 5 here because this is the fifth term. So again, just simply manipulate the resulting expression for you to come up with the first 5 terms of this sequence. So the arithmetic sequence. So here we have to deal with the definition and identifying arithmetic sequence. And let us start with the definition. So an arithmetic sequence is a sequence where each new term after the first term is found by adding a constant number to the preceding number. The constant number is called the common difference. So let us proceed with identifying arithmetic sequences. So here are some examples. So our goal is to identify if the sequence is an arithmetic sequence, and we need to indicate the common difference if the sequence is an arithmetic sequence. So based on the definition, we must have a constant number being added to the preceding number so that we get the next succeeding numbers, and we call that the common difference. So here we only need to check whether there is a common difference between the pair of terms. So looking at our negative 4 and 1, so difference means we need to perform a subtraction. So here we have a 1, and if we subtract a negative 4 from which then we get a positive 5. So let us check whether this pair of numbers 1 and 6 gives us the same difference of 5. So having our 6 minus 1, which gives us a 5 as well. Now we also need to check whether 11 and 6 gives us a 5. So having the subtraction be 11 minus 6, so that gives us a difference of 5. So we call this a common difference because all of these differences or those corresponding pair of consecutive terms are all the same, which is equal to 5. So that is a common difference. So we say that this is an example of an arithmetic sequence whose common difference is equal to 5. And let us consider other problems related to arithmetic sequences. So here we have, what is the next term in the arithmetic sequence? So since the problem states that this is an arithmetic sequence, then we must have a common difference. So to check our common difference, then we may use the second term and the first term. So having the difference of these two terms, we can, so let me do some scratch work here. So we have the negative 4 minus negative 13 for our common difference, which is equal to 9. our common difference is equal to 9. So now that we have our common difference, then we just have to add this common difference to that 14 so that we get the next term. So 14 plus 9 gives us 23. So that means our answer would be 23. So the next term is 23. So next, what are the next two terms of the arithmetic sequence? So here we are asked of the next two terms. So again, we must use a sub 2 minus a sub 1 to give us the common difference. Our a sub 2 is negative 3, while the a sub 1 is 7. So negative 3 minus 7 gives us negative 10. And the same with our previous example, since the last number in the sequence here is negative 23, then we may get the next term by adding the common difference of negative 10, which gives us a negative 33. So that means the next term is negative 33. But the question asks us to find the next two terms. So we must continue doing this time using the negative 33 plus the common difference of negative 10, which gives us negative 43. So the next two terms are negative 33 and negative 43.